Our next talk will be by Lydia Fletcher from TAC. And Lydia will talk about open science for iHARP.
Can everybody hear me okay? Hi, everyone. I am Lydia Fletcher. I am from the Texas Advanced Computing Center. I only started working with iHARP back in January, so it's only been about 6 months. And one of the things that I was asked to do is to talk about open science and how iHARP can be incorporating open science into the work that it's doing. So I'm going to talk a little bit very generally about, and I only have 10 minutes before the breakout session, so we're not going to get in depth into a whole lot of the issues around open science, but I'm going to kind of talk broadly about what that means and talk a little bit about what iHeart folks can be doing right now. But my main objective here today is to get you all to know that I'm here. I'm a resource when you have questions or when you need help navigating these issues. I'm the person that you can talk to. I'm here to help you guys. I'm going to be producing kind of a guiding document over the next couple of months that incorporates some of the feedback I've gotten from talking with different folks on iHARP. But yeah, I'm here to hear what you guys need from me so that I can help you better do science that's big and open. So just as a general kind of overview, open science isn't really a new concept. It's kind of an evolution of a bunch of existing concepts that are coming together at kind of like a confluence of, open source. The idea of open source code has been around for a long time. Open access publications have been around for a long time. Open data is kind of a newer concept, but it's, newer in that it's been around for about 10 years. It's been, kind of gaining steam. And open science has become a big topic of conversation, especially in the last couple of years, because the White House put out a policy document in 2022 saying, people who are creating data must start publishing their data as soon as possible. And of course, that sounds very scary. Like, how do we make our data available? Where do we make it available? What do we need to do to meet these new requirements? It's not that scary, I promise. I answer that question a lot. But the whole goal of open science is really to try and, increase the reproducibility of science. So it's getting to this idea of you have these machine learning models and you're wanting people to be able to take the model that you've created, the data that you have used, put it together and reproduce the results that you got. So there's a lot going on, and it's a way of trying to embed these ideas of openness at every step of the science research life cycle. So it's very big, very complex. For a project like iHARP, there's a lot of moving pieces. There's so many different projects going on, and each of those projects has so many different pieces to them. How can you embed openness and all of the ideas of openness at every single step of the way? It's a big, big topic. So again, I think that reiterates what I just said. I forgot to click over to my new slide. A great kind of way that I think about embedding open science in doing scientific research is the use, make, share framework. So you want to be using code and data that is already open, that is already openly available. You want to be making your own code and data available. We just heard a great description of sharing a whole bunch of new algorithms on GitHub with open licenses, and that's amazing. That's exactly the kind of thing that we want to be doing. And then sharing and getting all of that stuff out there. Some key things to note is that open science is really something that can be practiced by everyone at every level. So from undergraduates or high school students and middle school students, all the way up to, our PIs on all of our big projects. It really is an idea of kind of these concepts get embedded in your whole life cycle. And that's, really challenging because, like I said, there's a lot of moving parts. There's a lot of different ways that things can be open, and openness doesn't mean the same thing for data that it does for models. And so trying to navigate that's what I'm here for. So what can iHeart be doing right now? What kinds of activities can you guys be doing right now? There are so many good resources already available to learn about open science and to learn about how it ties into each different piece of the research that you guys are doing. I love the NASA Transform to Open Science 101 course. It goes through, it's a whole bunch of different modules, and it's kind of time consuming. Have a graduate student do it and report back. I found it incredibly useful. It goes into really nitty gritty details about open source code, and um, it goes through the open source definition that has been around for a while, but that really kind of gets to the core of, you know, how do you take code and make it open? And I think that as we're coming into this era of AI and machine learning, and these kind of black box algorithms that people are somebody mentioned ChatGPT earlier. Can ChatGPT replace a data scientist? Well, we don't know how ChatGPT works, so I would say no, it cannot replace a data scientist. But I know Christine is really involved with the Fair for Machine Learning initiative, trying to kind of get those concepts that have been around for data for a while applied to machine learning, so that people understand how you trained your ML algorithm. They understand why you got the results that you got. They understand the different types of data that you need to run a model or algorithm, etc. And then, of course, understanding what the FAIR principles mean and how you can use those in your work. And part of that, and the thing that I really want to talk about, because I think it kind of came up, there was a question earlier about the ERA 5. I think Christine asked it about, so you've got this ERA 5 data, which is this huge, massive data set, and you've subsetted it into these derivative products, and now you're going to make those available. What's the license on that? Because that's an important thing. You need to understand, like, what are the restrictions for use and reuse that are applied to that data. And in the US, if it's federally funded data, that's kind of easy, because if it's federally funded data, it belongs to everybody, and you can make derivative products and publish those products, and everybody lives a happy life. But if it's coming from, I think you mentioned working with Planet Imagery with some private satellite data, what are the licenses for publishing that data set that you guys have created? I know that other people are working with other private satellite companies to get different data sets. So it's kind of understanding, what are the restrictions, what can and can't you do with the data that you're using from where you got it, but then also, like, how do you want to restrict, or how can you restrict the data downstream? If you're working on a federally funded NSF project, you can't put restrictions on your data once you publish it. It belongs to the US the US citizens, the public. It's the world's. So you can't put a license on it that says, I don't want this used for commercial uses down the line. But those are the kinds of things that, people need to be thinking about. Luckily for y'all, I've spent 10 years of my life thinking about exactly these things. I worked as a science librarian before I became a data librarian at TAC, and so I understand licensing issues really, really well. When you have questions like that, you can come to me. I don't know the specific answer. Ooh, what did I just do? I don't know the specific answer about ERA 5, but I will know it when you guys come ask me about it later. I put a whole bunch of links in this slide just as kind of general reading and information for everybody, so that you can learn for yourself to the extent that you're interested about all of these different issues. If you have questions, though, like I said, I am here, I'm available, I'm a resource. I would love to know the questions that you guys have right now, and I would love to be able to kind of help you navigate how you and your students, the people in your lab or the people on your projects, can apply some of these techniques or these practices in your day-to-day work. And look forward to hearing more from me. I think I'm slated to give a longer Tuesday talk at some point in the near future, where I will probably be talking in depth about licensing issues and reuse and things like that. But I'm here now.
Thank you, Lydia. Any questions for Lydia?
I think we have 1 minute, but I will also be around, so
yeah.
people can feel free to grab me
Yeah.
at any time.
I-
Just so people know this, and Lydia has just joined us in January, and one of the things to do is Lydia is visiting each of the project meetings. So if you hear from Lydia, please meet with her and discuss your project and the data sets or the reuse that you have going on. I think it's very important for each of the projects to be engaged one-to-one as well. And you heard different snippets of open science efforts. So there's a concerted effort that we're trying to do on all fronts. And hopefully Lydia can help us, chart a pathway, big task I'm putting on your shoulders, but something to look out for. So if each of you are reached out, just make sure you're available to talk, Jim.
And one thing that I'll mention just quickly is I do have iHARP is funded an REU at TAC for the summer. And so I have a great student working with me. And what she's been doing is going through the data sets and the publications that we already know that people have been working with, like ERA5, like the Sentinel data and things like that, and creating kind of a standardized data catalog of data sources that people from iHARP will be able to use. I think the idea is to put some of that data in GHub so that it's just readily available and loaded already for people to use. So that's another thing to look out for at the end of the summer.
Yeah, I think it's not too much question, but comments. I think this is a definitely very good efforts, and also with the GHub, it's another frontier. I think maybe there's what's the connection between these two? If all the codes put to the GHub is done with open science, or what else do we need to do? I think does GHub take care of both data and the algorithms? I'm not sure. I think we probably need to find a solution together. How particularly from Lydia, from GHub together to make it a complete story for the open science for iHARP.
Yeah, licensing is only one piece of the puzzle, but documentation, like really robust documentation and metadata is a huge part of it, and that's really difficult. And so, yeah, when you're putting things in GHub, that's another thing to be aware of, and that's also something that I can help you figure it out.
A little bit of a discussion on that, because there's one side of the community. We were talking about the two sides of iHARP, right? There's the polar science and also the computing fields, and this is a big spectrum. So I think there's different pieces that go into the puzzle, like the example that Mike was sharing and the GHub example. I don't think there's one solution fits all. We do have to reach different parts of the community, and one of the things that GHub uses as a foundation is GitHub and DOIs that are required for code and data. For the polar science community, anybody can use it, but the polar science community has access to it. But there's a whole host of other things that we don't know yet. So one of at least my hopes is that when Lydia starts visiting each of you in your projects, there will be other things that will come out, that there's a common theme, like GHub came out of the last year's meeting. Maybe something new comes out, but I don't think that there's one solution, one piece that fits all.
Thank you. Maybe one quick question from me, Lydia. In terms of the NASA TOPS program, which is, I think, relatively new compared to NSF, do you see commonalities between the two in terms of funding that they provide for open science and differences between the two?
Yeah, so I think that NASA has been, so NSF has not finalized their new open policy document. It went out for public comment that closed in January of this year, I think. So NSF hasn't made their final formal kind of like, this is what people must do in the future. NASA is a bit ahead of them in that, they're now, instead of just requiring a data management plan, they're requiring an open science plan, which goes into not only what is your data management data management plan, what is your code creation and sharing plan, what is your personnel to devote to these different areas. So there's 5 different pieces of the NASA Open Science Plan document, and I think that that's it's very comprehensive. Yeah. NSF does not have anything similar at the moment. They're still just on the old data management plans, but they are starting to require that people publish the data as soon as possible. And that's still a very malleable term. So things I think will be changing, especially over this year. I think folks have to have their plan responding to the Nelson memo from 2022 by the end of this year. And to take effect next year. But then, of course, this is an election year, so who knows what's going to happen. But yeah, that's the kind of stuff that I live and breathe day to day. So come talk to me.
Thank you again, Lydia. And if you're interested in medieval literature, I learned today, Lydia is an expert on medieval literature as well. So she has great recommendations for that too. So thank you.
Thank you.